All right, so this is the final set of pages for our lesson 16, solving systems of equations algebraically. We have the three ways that we could solve a system, and it's through graphing, substitution, or elimination. All right, so number one says which statement about this system of equations is true. So, and it's talking about how many solutions it has. When it's talking about how many solutions it has, you need to make sure you put both of the equations in slope-intercept form, which is y equals mx plus b. The top one is fine, but I need to make sure I simplify it as well. And it simplifies to y equals 4x plus 2. The bottom, I need to move that negative 4x to the other side, so I'll move its inverse. So y is also equal to 4x plus 2. And if you notice, they're the exact same equations, so the number of solutions is infinite. All right, moving on to number 2. Same thing, if I'm trying to figure out how many solutions it has, I need to make sure that every single equation is written in slope-intercept form. And then I'm just going to shade how many solutions it has. So for the second one, I can already do that because I can see they're both already written in slope-intercept form. So I have my 2 and my 2, same slope, but different y-intercepts. One's 6, one's -9. That'll give me no solution. The bottom one is super easy to do as well. So all I'll do is make sure I have my y on the side by itself. So I'll really just swap that y and that 4. And again, I'm moving across an equal sign, so I'll swap them using their opposites. So I'll have 6x minus 4 equals y. And then over here, I had y equals x. So they clearly have different slopes. One of them is 6, the other is 1, is an invisible 1. So if I have different slopes, that's one solution. All right, this third one, I'll just move on to this one. What I'm going to do again is I want my y on the side by itself. So I have my y's. And then I need to move my x over here. So I have minus x. And then I'll divide everything by -3. Divided by -3, divided by -3. So I've got positive x over 3 minus 7/3 for the top one. For the bottom, I'll move my 2x over here, so I'll subtract 2x, and I'll divide everything by -6. So y is equal to, again, I've got x over 3, because that's 1/3 x, which is just x over 3, minus 14/6, which simplifies to 7/3. They're the exact same equation, so this is infinitely many solutions. And then finally, for that first one, we can see that when I go ahead and do it, again, I need my y's to equal something. So I'll move the 3x's to both, and I'll have a -3x. They're gone. And then I have to divide everything on the top by 4 and everything on the bottom by -4. So for the top equation, y is going to be equal to -3/4 x plus 5/4, and the bottom, I'll write that over here. The bottom one, I've got y equals 3/4 x, so that's positive 3/4 x minus 1/4. If you notice, I've got different slopes, and as soon as I see I have different slopes, that is exactly one solution. And I'm done with this problem. I know I was kind of like all over the place, but I just do them in different orders. All right, number 3. The graphs of lines A and B are shown on the coordinate plane. Match each line with this equation and write the equation on the line provided for each line. Then solve the system using any method. Okay, well, I can easily see the solution to this system is going to be 4, 3, because that's where the two lines cross. So the solution is 4, 3. And I just need to write the lines, or write the equations for each line. So line B starts at -4. Starts at 5. And then I just find the slope. I choose any 2 points I want to. I go down 1 and over 2. So that slope is -1/2 for line B. And I've got my whole thing. I've got everything I need. The slope-intercept formula is y equals mx plus b. My m is -1/2. I got x, and then plus my b of 5. I'll subtract that. And that one happens to be here. Got it. So y equals -1/2 x plus 5. All right, and then I'll do the same thing for line A. I can see that my b is -9, and then I just find my slope using any two regular points I want to. So I go up from 9 to -3. So that is up 6 and over 2. So my m is going to be 6 over 2, which is 3. So my equation would be y equals 3x minus 9. And that's this one here. And we are done with number 3. Actually, they asked me to write the equation on the line as well, so I'll make sure I do that. Y equals 3x minus 9. And now I'm done. All right, moving on to number 4. It says, you know that the only solution of a system of two linear equations is -2, 1. Graph two lines that could be in this system of equations. Label the lines A and B. And then what's true about the two lines and what must be different about the lines. So I'll label this pink line as line A and this black line as line B. All right, so what must be true about both of them? They both have -2, 1 as a solution. If it's a solution to the system, it's a solution that lies on both lines. So -2, 1 lines, let's say, is a solution to both equations. So it's found on both lines. And then what's different about them, if you notice, whether you made your line, one of your lines slopes be positive, the other negative, even if you made them both positive, no matter what, they have to have different slopes. So what's different about them is the slopes. Slopes must be different. Slopes, well, let's just say the slopes are different. Okay. All right, and it said it was the only solution, so they had to have different slopes. They could not be the same line. All right, and then we move on to number 5. Number 5 says, using the lines that we drew in problem 4, write the equations for them and show how to get the solution using either substitution or elimination. I'm going to choose substitution this time, and I'll just choose substitution first and then elimination second, so you can see that it works either way. Actually, I'll just do substitution up there and elimination at the bottom. Makes more sense. Okay, so let me go ahead and write out my equations. So line A, I made sure when I drew this too that it was super easy for me to find my slopes and y-intercepts. So I was very clear about what I did. So for line A, I can see I go up and over 1 to get from one point to the next, and my y-intercept is 3. So my y-intercept is 3, and my slope, I go up 1 over 1, so it's 1. So my equation for line A is x plus 3. For line B, my y-intercept, as you can see, is -1. And for my slope, I just go down 1 and to the right 1. So that is -1 over 1, which is -1. So this equation is -x minus 1. All right, and so now what I'm going to do, since I have a set of opposite x values or x variables or whatever, I'm going to go ahead and add them together. So I'll have 2y equals 0 plus 2, and this is actually elimination first. Do that method first. And then I really have 2y equals 2, divide by 2, divide by 2. Y must equal 1, which that matches. And then I just find my x. So I know that y equals x plus 3. So 1 equals x plus 3. I'll subtract 3. X equals -2, and that also matches. So elimination works. So I know for a fact this is my solution, which obviously makes sense because that's what I drew it to be. And then I'll do the same thing with substitution. I had y equals x plus 3 and y equals -x minus 1. I'll just go ahead and set them both equal to each other. So I'll add x So I've got 2x plus 3 equals negative 1 minus 3. So 2x equals negative 4, divide by 2. I find that my x is negative 2, which of course matches. And then finally, I just go ahead and plug that into one of my equations. I'll just choose the top one, because why not? And it doesn't have any negatives, so it's super easy to look at. So my y is equal to x plus 3, and my x is negative 2. So y equals negative 2 plus 3. My y is equal to positive 1, which also matched with our solution. So I know for a fact we are done. And that is it for lesson 16. Thank you.